What does Vault have to do with cooking potatoes? Well, everything. But before we kick off, yeah, as my colleague Dami said, I am a solution engineer here in the UK and Ireland. That means I talk to a lot of different teams, doing things differently, right? And kind of it's my role in life to go in, talk to them, and understand where our different solutions can fit in to their process flow, and kind of where do we bring value, right? And I started noticing a pattern. If I come back over here to my whiteboard, right, I just threw up some scenarios here. And these scenarios have one thing in common, which is they need secrets, right? If we're going to provision resources via CI/CD pipeline, if we need PKI certificates for our Kubernetes applications, if we want to have, a cold storage of our Unix passwords, and if we want to be able to interact with a blockchain network without needing to expose our private keys, right? All of those have secrets. Now, the first question that I get asked when I pretty much go anywhere is, how do we manage our secrets? It's a fine question itself, but it's not a really useful question. And kind of modesty aside, because the answer to that question is use Vault. The problem is this kind of leaves us exactly where we started, right? It's a very consultant answer. Sorry, I was a consultant, so I can make this joke, right? It's like, it leaves us pretty much where I was without giving me any value at all, right? Okay, it doesn't give me sort of any explanation. And okay, how do I use Vault? All right, what are the things that I need to worry about when I'm actually implementing Vault itself? So where Vault fits in to our different use cases, there's a different question that we can ask ourselves. And the question is, when do I need my secrets? And there's a different part, which is, for how long, right? Let me just zoom into that. So when do I need my secrets, and for how long do I need them, right? And that is an interesting question. And the reason that is interesting is that it kind of starts giving us the idea that secrets have a time to live, right? Secrets are not something that I need to know once and that's it, right? And no, it's something that you use, and you don't use it all the time, right? You don't need to have them on you. Like, it's not, the keys to your house are secret, but it's not like, all right, when do you actually need the keys to your house? Well, when you want to go into your house, or you want to leave the house and you want to lock the door, right? You don't need those keys to exist always. So when do I need my secret is a good question to ask, because it will start going into the habit of good secret management. Okay. Now, how do we answer this conversation? How do we answer this question, right? To answer this question, we need to think about the value of Vault, right? Why Vault exists, and in general, why HashiCorp exists, right? And the way that I like to answer this question is, well, the value of HashiCorp, and more specifically, the value of Vault, is an abstraction of complexity, right? If you think about Terraform, right? Terraform is there to abstract away the complexity of provisioning resources, right? I have one language, I have one style of infrastructure as a code, and regardless of the resource that I want to create, the process that I'm going to create is the same, right? If we think about console, right? Console is a service connectivity solution, right? And the value of console is taking away the complexity of getting services to talk to each other, right? I have my load balancer, I have my service mesh, and kind of seamlessly, I just say service A needs to talk to service B, and that's it. The same way like Nomad removes the complexity of running different workloads, right? I just create my Nomad job and I say, here, compute pool, run this. And I can even say if I want it to running always, how many instances of it I want, if it's going to be a batch job, and there are different varieties of it that I can, or like different details that I can put into that job. But I no longer need to worry about as much. Okay. And with Vault, well, Vault abstracts away the complexity of secrets management, right? So again, how do I manage my secret? The answer is use Vault, because it's simple. It's multi-data center. I can run it on Kubernetes, any of the cloud providers on-prem. It's abstracted away from the complexity. All I need to do is use it. Cool. Now, to start implementing Vault, I'm going to use the royal we here, but it was actually the really smart engineers and geniuses over at the Vault team, right? But to start using Vault, the quickest way that I found, and kind of I forgot the word that I'm thinking of, like the way to think about a Vault project is to break it down into different parts itself, right? Now, and breaking this down pretty much can follow the way that Vault was built, right? So let's tackle the secrets management problem, right? Let's come move this over a little bit so we can have a nice clear whiteboard. And let's come up with a secrets management solution. So let's come up with Vault. Well, who uses Vault, first of all? Well, Vault can be used by many different applications. It can be used by human clients, right? There are different people that need secrets, machine to machine, human to machine, and so forth. Different languages, we've got Java, Python, API, Java, Python, Go, C++, Rust, Rails, on and go, right? Ruby on Rails, that's what I mean, right? So instead of saying, this is how you interact with my secrets management solution, right? And start specifying like how you're going to use the solution, let's come up with a way that it's used in many different scenarios. So pretty much all of HashiCorp's tools are API first. That means that any feature that is created on any of solutions, but specifically Vault, starts with an API, right? And then any kind of client software is built on top of these APIs. The user interface, the web client for Vault, is built on top of the APIs. And all of the libraries are built on top of the APIs. And all of these are facilitators to interacting with the solution itself. Okay, cool. So now we have a way of connecting to our secrets management solution. Let's say we have the foundations of our building. Right? The next little bit is going to be an enterprise bit, but this comes from feedback from our customers that says like, all right, instead of having different Vault clusters everywhere, I want to be able to make Vault multi-tenant. Right? So because it is an enterprise feature, I'm not going to focus that much on it, but I will just put it in here that you have namespaces. Okay. And namespaces are basically your multi-tenancy, right? If we think, all right, we're creating a building, namespaces is going to be the difference if it's going to be a warehouse or a skyscraper, right? So we have our foundation, which is our APIs. We have a way to get to our building, and namespaces, which decides if we're going to have a warehouse or a skyscraper. Cool, right? Now we need some way to go ahead and access that building, right? The space that we want to use. We need to provide that authentication to it. So after we have our namespace or not, what we start defining is our different authentication methods, right? And why authentication methods? It's because Vault is abstracted away from where it's running from and who is interacting with it. We have different ways of actually getting that authentication, that auth-n. Right? By default, you come with your token, right? And everything comes down to a token. But if you are running on a cloud provider, right, and your cloud provider can act as your trusted source of identity, you can use any of these kind of AWS, Azure, or GCP, and on and on and on, right? Authentication methods. You can say, yep, my application that is running on my cloud provider, I trust my cloud provider to run that application. So I'm going to trust it to give access into Vault itself. Right? If I'm running on-prem and I'm a human, right? I have my Active Directory or my LDAP or my OIDC. Right? Secret methods. So you have that interaction with that identity provider. If I'm running on Kubernetes and I have different namespaces, I can just say, yep, Kubernetes is my identity provider, and off I go. And if I have none of the above, we do have a really interesting one, which is called April, which is kind of imagine an improved machine version of username and password, which is a bit more dynamic. And April is great. Like pretty much if none of the above fit, April is the answer. Okay. So that solves the authentication, right? That solves our way into the building or our way into the space that we're going to use it. Cool. What's next? That doesn't mean just because we have like the keys to the building, we have the keys to the kingdom, or we can do whatever we want. No. Next is to start defining our personas. Who's actually going to use Vault? What are they going to do with it? Things like that. So over here, we have then our policies. Now, there are two types of policies. We have our ACL policies, which is our what can I access? What can I do with Vault? What do I need Vault for? So for example, if I'm an application that all I do is encrypt secrets, that means that I don't really need to decrypt. So that means that I really don't need to have the principle of least privilege. I don't need to have the privilege of decrypting what I encrypt. All I encrypt, that's all I need. That's all I need access to. And if I need one specific secret, I have access to that secret and nothing else. This is the what. Vault Enterprise also comes with another policy type, which is available on all our enterprise solutions, which is called Sentinel. Right? And this is policy as a code, but this pretty much defines the how. Right? Or this is the governance piece. Right? And this, with Sentinel policies, I start defining how people are going to use my solution. Right? If I say, yeah, okay, any certificate that I'm going to generate can only be valid for a month, a day. If people can only access Vault from a specific subnet or from Monday to Friday, 8 to 6 kind of things, I can start putting in those governance best practices into my usage of Vault itself. Cool. So, all right, we have our foundations. We have our way to talk to Vault. We have the way to do the authentication. We have the way to do the authorization. What's next? Well, secrets, right? It's what Vault does. It's what our secret management does. So the next box that we have over here is our secrets. And there's a reason I put secret engines there. Going back a bit, we talked about abstracting away complexity, right? And we talked about, right, 5%, we can do this. Right? We talked about, it abstracts away complexity, and we just have Vault to manage our secrets. So secret engines is that abstraction, right? Instead of saying, okay, these are the only secrets that you can store with Vault, we say, no, you have different ways of managing secrets, and you have then different secrets to manage. And there are three main secret types that we see usage in general, right? The first one is when I have something and I want to store it securely. And this can be credentials, this can be certificate, this can be anything, right? So pretty much it's a static secret that I want to store it securely. It can be my private keys to my blockchain solution, right? So we have our static secret engines, and the implementation of this that we see is key value, right? I give it a name, I say what I want to put in there, and I go ahead and store it. Right? Kind of this is where Vault started. This is where it all started. Okay, let's install in our credentials in here, install in cloud credentials, install in database credentials, install in any certificates that we need to SSH into different machines and so forth. What happened was we kind of started reviewing that and seeing, you know what, when do we actually need these secrets? You know, when do I need cloud credentials? When do I need database credentials? Well, I only need them when I'm going to use them, right? So the second secret type is, instead of, just having something and putting it into Vault to store, what we can do is configure Vault and give it enough permissions to go out and create these secrets for us. If I just move up a little bit. Now, this is what we call dynamic secrets. Right? And to start off with I think the first one out of the gate was cloud credentials. So if I need to access AWS, I have a dynamic secret there. If I need to access Azure, I can have a specific secret engine to do that. GCP, no. Instead of like having a long-lived credential to those cloud environments that may leak, right, when I'm not using it, or that I need to worry about managing it, I just hit up Vault and say, hey, Vault, can you generate me some credentials to the cloud for like the next day, the next week, the next month, and things like that. Right? Along with this, the same thing for like databases, right? Instead of having my different long-lived database credentials, I can just hit up Vault, say, hey, Vault, can you give me a database user for the next day, next hour, the next month, things like that. Now, if we take this idea further, the other thing that we can do as well is then have Vault facilitate my SSH access management, right? Then I can hit up Vault and say, hey, Vault, can you sign this certificate for me so I can access this node using my public keys? And then Vault saying, yep, you're good to go for the next hour or so. Right? And it just facilitates that integration. And then the last one, because we have this idea of I can generate on demand, what we can do is have Vault as well generate different PKI credentials, because PKI certificates, right? Short-lived ones. Instead of having to create long-lived certificates, I can create short-lived certificates on the fly, and we're back. Right? And this is specifically useful for things like Kubernetes clusters, where I may want a self-signed certificate for the applications running in my cluster, and I don't want to have to give my internal CA access to those applications. Cool. Now, there is another secret type that is what happens when I don't want Vault to generate anything for me, or I don't want to store something in Vault, but I just want Vault to change my secret. And we have here is the transit or transform. secret engine. I'm just going to move again to the side here because I hit my USB cable and it kind of changed everything around, right? So we have these transit and transform secret engines. And what are these, right? Transit is pretty much encryption as a service. Instead of having to worry about, where do I put my private keys and give them out, and kind of what are the encryption libraries that my developers are going to use, and kind of have all those worries. How do I rotate my keys then? Facilitate the problem. What do my developers need to do? Encrypt and decrypt. Here's a secure API you can give you can use on your deployment, your development, to encrypt services, right? You give in your plain text and it brings you back your cipher text, things like that. On the transform bit as well, it kind of is an idea. It is the next logical step from that, which is, okay, let's take this idea of transformation and take it a step further, doing things like total disk encryption, format preserving encryption, tokenization, KMIP interface, a KMIP server, so we can generate our keys there. And another one, which is still in technical, still like in beta, we're still getting it out there, is the key management one, which I'm specifically not allowed to mention, which is like BYOK, key distribution, basically. If I need to maintain that root of trust, and I need to be able to give a specific key to my SaaS environment, right? The key management secret engine can help do that. So like I say, hey, Vault, generate this key and securely distribute it to an Azure KMS or any other KMS services or a specific SaaS provider, right? So there. And the good thing about Vault is that all of these are audited, right? So every request and response, now let's do this a little bit better. Okay, here. Every request and response into Vault is audited when we've enabled the audit devices. Right? So that means that I am able to have that governance. I am able to have the visibility of who has done what. So the kind of the secret of implementing Vault is thinking of a Vault project like this. Right? And to specify this, because I don't have a lot of time left, we'll just kind of work on this first scenario, right? Provision resources via a CI/CD pipeline. Well, okay, when do I need my secrets? Okay, I need my secrets before I actually start running Terraform. Okay, perfect. So for how long do you need those secrets for? Right, I need them for 30 minutes if I'm going to do something that is like takes a long time. I'm going to do a lot with Terraform, or it can be down to like 5 minutes if I know that my Terraform run doesn't take longer than that. Right? Okay, perfect. If I am doing this via a CI/CD process, right? How do I want to interface with Vault? Right? Is there a custom library that? Is there a library that facilitates this communication? Is this something that I want to think about, or should I just do direct API calls? Okay, you can just do direct API calls. Okay, perfect. Do I need namespace or not? Am I a Vault Enterprise customer or not? Let's say no. Right? So we don't need to worry about namespaces now. Okay, what's my auth method? Well, we're running our CI/CD solution on Kubernetes, so we can have Kubernetes manage those for us. Or no, we want to have each specific pipeline to have its own access into Vault, so we can use April, and each pipeline gets a specific April, a role ID and secret ID. Right, cool. Right. What are the secrets that, what are the policies that we're going to use? Well, we only read it from an operation perspective. We only really need to generate the secrets. So that's your personas would be, all right, generate secrets, and then that's it. Like, we don't need to give admin access for our provisioner. Okay, cool. And again, the time to live, it's going to be 5 minutes, right? So this way, I can have the visibility of what this process is doing, right? Because if I think about my implementation in this way, it's kind of easy to break down, or it becomes easier to break down the process of implementing Vault. Right? Now, I talked a lot. We did some design. What are some takeaways here? The takeaways is, technically, Vault's easy. And there is a lot of great documentation on learn.hashicorp.com. Right? And one of the things that I will leave you guys today, it's again, leave you folks today, is it's not great, but it's helpful, right? I have a little Vagrant playground. If you want, I'm just going to go ahead and click here. That spins up a Vault solution, a Vault cluster. It's not even a cluster, it's just a node and a consumer. So if I go ahead and click my Vagrant file, I can see that I have, all right, Vault, and in this specific case, Minikube, because I was actually going to implement all of those use cases, ended up not happening. Right? And I will pop this in chat in a little bit. All right, Rosemary already did it. And we can, yeah, and feel free to use this if you have any improvement on it. If you're shocked by the lack of documentation and want to document this usage, please feel free. I'm always happy to accept PRs. If you have any question, again, feel free to reach out. And yeah, that's what I wanted to say. So the secret of implementing Vault is that there is no secret, but the architecture itself holds the way that we think about the Vault implementation, right? Thank you for having me, and reach out if you have any questions.